Hey folks, welcome back. We're going to start looking at functions from a graphical standpoint now. So we already talked a little bit about how functions behave, looking at specific points and looking at some of the equations and notation for functions. But what about the actual graphs? How do those tie into this whole mess? So a couple of things about the graph of function. So we can actually create a graph a lot of different ways. But we have a few of them listed here. So one of the first ones is obviously we can use a table of ordered pairs. So if we create a table, obviously that's going to help us start to get a graph drawn. We could then plot the points and then sketch the curve. Now we talked before about how that can sometimes be misleading depending on the complexity of the equation that you're looking at. Same idea for functions. And then obviously we have technology ways that we could look at graphs as well. Graphing calculators are a great way to get a good, accurate sketch. But again, sometimes they can be a little bit misleading depending on the complexity of the equations. So let's just go through a few of these processes and see what we can do. So this first set of examples wants you to make a table listing ordered pairs that satisfy each equation. Then graph it, determine the domain and range, and whether y is a function of x. So a lot of layers to this problem. Okay, so let's first get a table. Now I'm going to make a table vertically just because it'll be a little bit easier. Now we're not 100% sure if we have a function, so that's why we're not using function notation yet. But we could once we determine that it is indeed a function. But for now, let's leave it as x's and y's. So now our graphs are all centered around the origin, so it doesn't hurt if we wanted to start at 0 and then kind of branch our way out from that. So usually people like to start with x. I would recommend the same thing. So if x is 0, we're going to get a -1 for y. If we plugged in a +1, well, 1 squared is 1, 1 minus 1 is 0. And we could zigzag back and forth or keep going with positive values if you want, it doesn't matter. Let's go to 2. 2 squared is 4, 4 minus 1 is 3. Let's maybe go to the negative side, -1. -1 squared better be +1. 1 minus 1 is 0. And let's go to -2. -2 squared is 4. 4 minus 1 is 3. So we kind of got a sense that there's some symmetry going on here potentially. But let's take a look at the picture. So we got 0, -1, 1, 0, -1, 0. 2, 3, -2, 3. Well, so what do you think we got? Hopefully you're screaming parabola, which would be right. So there's our sketch based on our table of values. Determine the domain and range and whether y is a function of x. All right, well, let's just go down underneath here. So what would be the domain of this function? So remember, domain is what values of x can we plug in and get something out. And hopefully you can kind of see that no matter what value of x we plug in, we're always going to be able to get a value of y. So the domain is all real numbers. And remember, our set notation would be to use parentheses with -infinity to infinity. So what about our range? So what possible y values can we get out? Now, it's not going to be all of them. We can't get every value out. We can see that there's this open space down below here. So those y values are not getting hit. They only start right here is where the y values start getting hit. at -1, and then it keeps getting hit all the way up forever. So we want to include -1. So we want to use a square bracket, and then we want to keep going all the way through infinity. So we got most of this answered, but now we got the final question. Is y a function of x? So we have all those conditions, but the main one is, does one value of x give you one value of y? And the answer is yes. No matter what value of x we pick, there's only one spot it's hitting. You know, it's not hitting up here and then hitting down here or something weird like that. It's only hitting one spot on the graph. So this is yes. Yes. Y is a function of x. Boom. All right. Let's go to the next one. So we got x and y. And let's start at 0 again. So if we plug in 0, 0 minus 2 is -2. Square root of -2 is nothing there. Well, what about negatives? Negative inputs. Not going to work, right? Nothing's going to make it positive, so we want no negatives. So what's the smallest value of x that we can plug in and get something out? It's going to have to be 2, right? 2 is the smallest. So when we plug in 2, 2 minus 2 is 0, square root of 0 is 0. So that looks like it's the smallest x we can use. And if we keep going up, 3 minus 2 is 1, square root of 1 is 1. 4 minus 2 is 2, square root of 2, which is approximately 1.414. And so that's going to be that. And so we can go from there, though. We can get a pretty good sense of what the graph looks like. Now, if we wanted another nice value of y, we could kind of figure that out, right? What would be the next nice value? If 3 gives you 1, I'm thinking it might be 6, right? 6 minus 2 is 4. Square root of 4 is 2. So let's stop there. Okay, so if we plot our points, we got one here at 2, 0. Now we're going to go to 3, 1. And we want to go to 6, 2. So you can kind of see it has that gentle little, kind of curves. All right, so we have our table, we have our graph, we need our domain and range. So what will we get for a domain and range? What values of x are we restricted to? And we can see it by the graph. Smallest one is x equal to 2 and up. And we want to include 2, so we want to use a square bracket. So what about the range? Well, again, we want those y values. The y values don't hit anything down here. They only start at 0 and up. So square bracket, 0 to infinity. And your final question, is it a function? Yes, one value of x gives you one value, well, one value of x gives you one value of y. So y is a function of x. Boom. All right. Well, those have been nice. What about ones that are not so nice? What about this one? It's solved for x. It's not solved for y. So right there is a red flag. Not always, but sometimes. Let's do what we did on the other ones though. Let's get a table. Now, because it is solved for x, we might want to reverse our roles in getting those ordered pairs defined. So let's start with values of y to generate values of x. Because it's solved for x, that's the only reason why we're doing that. So if we plugged in 0 for y, what do we get for an x? Well, 0, so let's say we get a 1. All right, well, let's plug in a positive 1 for y. 1 squared is 1, 1 plus 1 is 2, so 2 would be the value of x. All right, what about 2 for y? 2 squared is 4, 4 plus 1 is 5, so 5 would be the value of x. All right, let's go in the negatives. Let's try a negative 1. Negative 1 squared is 1, 1 plus 1 is 2, so we got 2 for x. And if we do a negative 2 for y, negative 2, 4 plus 1 is 5. So a little different. Let's plot our points. 1, 0 would be right there. 2, 1 is right there. 5, 2, 5, 2 is there. Okay. 2, negative 1, so over 2 down 1 puts a point here. And then over 5 and down 2 puts a point right here. So hopefully you're kind of seeing that we have a sideways parabola. So we had something that looks like that. Okay, that's what it is. Let's look at our domain and range. What values of x do we have? Or are we using? Not all of them. The x's don't start until we get to this 1. And it's in there. So we want to make sure we include 1 to infinity. What about the range? So one of the things that we've hinted at here with all of these domain and range processes is that we can kind of use a vertical line to help us with identifying domains and ranges. So just to kind of quickly go back, we have the domain is negative infinity to infinity. If we took a vertical line and we passed through the function from left to right, the one conclusion we should make is that that vertical line is always hitting the function. No matter where we stop, we're always hitting it. So that's why it's from negative infinity to infinity. But the range is limited. And how we can tell that using the same sort of trick is to use a horizontal line. If we start at negative infinity, we're not hitting anything until we get to negative 1. And then from negative 1 on, we're always hitting the graph. We don't care how many spots, we just care that we're hitting it for domain and range. So that's another trick that you can use to help just visualize that domain and range. So domain is vertical lines. We don't start hitting it until we get to 2, and then we're always hitting it. We don't start hitting it until we get to 0, and then we're always hitting it. So we can use that same trick here. We don't hit the graph until we get to x equals 1, and then we're always hitting it. What about the range? As we start at negative infinity and keep working our way through it, we're always hitting it. So the range is all real numbers. Now, final question. Is it a function? And remember that one question you have to ask. For every x, how many y values do you get? For every x, we're getting 2 y values, 2 y values, 2 y values, not 1. So y is not a function of x. Okay, last one. Table of values. This one is solved for y, so we should be good to start with x, see what values of y we get. So let's start it. There's 0. 1 minus 0 squared is 1. Square root of 1 is 1. Let's go to 1. 1 minus 1 squared, which is 1, is 0. Square root of 0 is 0. What about 2? 1 minus 2 squared is 4. 1 minus 4 is negative 3. Square root of negative 3 is garbage. All right, let's go negative 1. Negative 1 squared is positive 1. 1 minus 1 is 0. Square root of 0 is 0. Negative 2, you can probably guess, is a problem. So we're really stuck here. Now, just to make it a little bit easier to see, right now, let's scale it by 3s. Let's say this is negative 1. Negative 1, 0. 1, 0 is up here. And positive 1, 0. So we don't have any inputs beyond 1 or negative 1. I mean, we could try 1.5 and stuff like that, but that's always going to put us with a bigger number second, which will make it negative. And we can't take square root of a negative number. So what about the rest of it? Well, we're going to have to try values in between. So what about a half? Well, if we took a half and we substituted it in, a half squared, half times a half is a quarter. 1 minus a quarter is 3/4. Square root of 3/4 is what? Well, we can get a decimal approximation, but I'm thinking we get the square root of 3 over 2, which is approximately 0.866. My head's in the way. So we get that. So at 1/2, we get almost, we almost get, 0.87. So pretty close, so maybe right in here somewhere, I guess. And if we did negative 1/2, you're going to find we get the same thing. So that's going to put you right here. So it turns out we end up getting not a parabola, but a half circle. So a half circle is what you're going to get from this equation. And it's just going to be the top half, not the bottom half, because it doesn't have a plus or minus in there. If it had a minus in front, then we'd have the lower half. But just being positive, we only have the top half. And so now our domain and range is going to be finite. There's no infinite on this one whatsoever. So domain, you should see we go from negative 1 to 1. Again, use that vertical line. It starts at negative 1, ends at positive 1. That's it. Range, same idea. Horizontal line starts at 0 and goes to 1, and that's it. And then the final question, is it a function? It is, because that vertical line, you can see no matter what value of x we pick, we only get one value of y. So y is a function of x. Boom. All right, so we're going to stop the video here, and then we will pick up more of this and look at some of the conclusions we can draw from this in the next video. So see you soon.